In this video we are going to talk about definition of derivatives. So definition of derivative is something that we need to study before we study power rule, because definition of derivative was introduced before power rule came in. So let us look at the learning objective of this particular lesson. So at the end of this lesson we will be able to differentiate functions using definition of derivatives, and in particular we are going to differentiate polynomial functions, square root functions, and rational functions. So these are the types of functions that we are going to differentiate by using definition of derivatives. Now, what is definition of derivative? When we say we are going to differentiate using definition of derivative, this is what we are going to use. This is the main formula that we are going to use. It says f dash of x, that means this is the differential of f, that's why we denote with a dash here, which is equal to limit as h approaches 0 of f of x plus h minus f of x divided by h. So this is the formula that we are going to use, and I'm going to tell you how we are going to use this formula as we discuss some of the examples, because if I start explaining this formula it might not make sense, but when we will do example then this formula will actually make a lot of sense. So for the time being you can actually note down this formula, this entire formula, because this is the main formula that we use to differentiate a function using definition of derivative. Example 1, we have to compute the derivative of this function here, f of x is equal to 5x minus 3x squared. We need to find f dash of x, that's why we are denoting by dash here. This dash means it's differential of this function. So f dash of x will be equal to limit as h approaches 0, and the formula is here, f of x plus h minus f of x, everything divided by h. Now I will tell you how to use this formula. It says here f of x plus h, that means in the f of x function, wherever I see x, I have to replace that x by x plus h. Here I have x, so I have to replace this x by x plus h. So this will become 5 into x plus h. Instead of this x I have to put x plus h. Instead of this x I have to put x plus h. That is the meaning of f into x plus h. Minus f of x is entire of this function. This is f of x, 5x minus 3x squared, this is called f of x. F of x plus h, wherever I see x I put x plus h, wherever I see x I put x plus h, and this is just h. So limit as h approaches 0 of this entire portion here, we are going to do it next. Limit as h approaches 0, this is the same thing from the formula, this h comes here. Now we are going to talk about the top part here. So we use a square bracket and we are going to do this part now. Now we said f of x plus h, so we have x here. Instead of this x we are going to replace by x plus h, so that is why we are saying 5 into x plus h. This x is replaced by x plus h, that is what I said. Wherever you see x, you replace by x plus h. Minus 3, this minus 3 comes here, and this x is again replaced by x plus h. So x plus h, and then it is squared, so the square comes here. Next we have f of x. So f of x is entire of this function, that is why we are putting 5x minus 3x squared. Minus is here, 5x minus 3x squared is entire of f of x. So this completes the entire formula of definition. We are going to simplify that now. Limit as h approaches 0. So we're going to talk about the top part here, the numerator. H just comes along. Now let's talk about this square bracket. So everything that is inside this square bracket we are going to simplify now. We can expand this 5x, we can expand this 5h. This part here is a repeated factor, x plus h 2 times. So this needs to be expanded first. This one we can just expand straight away. So when we expand 5 into x plus h, we get 5x and we get 5h. This part here is repeated, x plus h into x plus h. So when we expand x plus h whole thing squared, this is what we get, x squared plus 2xh plus h squared. Now this 3 is outside here, this 3 can be expanded inside. Let's talk about this portion now. 5x minus 3x squared, it just comes along. Further simplifying, the 3 goes inside, this 3 expands inside here, goes inside here, and this 3 goes here as well. So we have now 5x plus 5h minus 3x squared minus 6xh minus 3h squared, and this minus 5x minus 3x squared is from here. So basically we have expanded this inside, and this one is still coming along. Now we can actually open this bracket, we can open this one. This minus is outside the bracket, so this minus is going to expand inside. So minus goes here, becomes minus, this minus goes here, becomes plus. So 5x plus 5h minus 3x squared minus 6xh minus 3h squared. This minus goes here, becomes minus 5x. This minus goes inside here, becomes plus. Minus minus becomes plus 3x squared. Everything divided by h. Now things can cancel. This 5x can cancel with minus 5x, and this minus 3x squared cancels with plus 3x squared. Now we only left with 5h minus 6xh minus 3h squared over h, and limit as h approaches 0. Now we are left with this portion only. So h is common on top. We can actually factorize h. H is common here, h is common here, h is common here, so we can factor h outside, and the other things are inside the parentheses here. So 5h into 5 becomes 5h, h into minus 6x becomes minus 6xh, and h into minus 3h becomes minus 3h squared. Everything divided by h. This h is from the formula. So clearly these two h can cancel now, because these two are now factors. So h is a factor of the top, and this h is alone at the denominator, so these two can cancel out. You are only left with the limit as h approaches 0 of 5 minus 6x minus 3h. So this is a place where you can actually substitute your limit. It says limit as h approaches 0, so wherever you see h, you can actually substitute 0 in place of h. So we have 5 minus 6x minus 3 into 0. Why we are putting 0 here is because of h. h approaches 0, so we are replacing h by 0. 5 minus 6x minus 3 into 0. This portion here becomes 0, and you are only left with 5 minus 6x. So this means that the differential of the function that we started with, so the differential of that function is 5 minus 6x. If you look at the area function that we had, f of x is equal to 5x minus 3x squared, we had to differentiate this. So these were the steps taken in order to differentiate that function, and this is the result that we get. Now in the next video I'm going to talk about more examples about definition, and probably it will make more sense when I will discuss more examples on definition of derivatives.